right triangle, and the circumscribed radius of the big circle. And we looked at different students' responses. So I want to know who you think is right and why. We looked at 4 different students. And I want you to say, when you tried it originally as a group, if yours was anywhere near that similar. So we got our first group going. Make sure you stick it underneath the camera so we can see.
We believe Logan's method is correct because he shows that you add the 3 triangles that are small to get one big triangle. And our answer was similar to his.
Can you show us your answer? Pull it down just a little bit.
Oh,
There we go. And so yours was similar. How was yours different?
Our number was a little bit higher than hers, so it was around the same.
Okay, thank you. My next group can go on up. My next group can go on up. Let's all go. Everybody goes. Okay, we're on deck next, right? So we're going to be ready to move as soon as you're done. There's 3, you're 4, 5, 6, and 7. Because I said that we're paying. All right. My next group, who do you think was right and why?
We think Aiden was right.
No talking, guys. I can't hear. Go ahead.
We thought Aiden was right, and I'm not quite sure why.
You're not quite sure why?
No, but it just seemed right.
Okay. Is it similar to your answer?
No, that's why I thought it was right.
You didn't think yours was correct at all?
I'm sorry, it's not that fun.
Go.
Okay.
All right, next group. Thank you. Next group. Okay, who did you guys think was the correct answer?
We thought Logan was right because all of the other people that said answers, the other 3 people, didn't make sense to us. Like they were just wrong.
So was the problem they didn't do their work right, so they got the wrong answer, or you didn't think their actual theory of how to do it was correct?
I'd say both.
Both. You didn't think their theory was correct or their answer. Okay. Was yours similar or different to Logan's?
Ours was different. Ours was higher than his
Okay.
number.
But you feel like Logan's is the more right answer, or yours was the more right answer?
Logan.
Thank you. Next group, please. Shane, can you move it down just a little bit towards you? Thank you.
Okay, so we think Logan is right because out of all the other people, his work made the most sense out of the rest of them.
What did you like about it? Just because this is one of the more common ones we
Because
see.
he used area, and I don't know, to me personally, it makes a little bit more sense than the rest of the theorems did. It's like less complicated in my opinion compared to the rest of them,
Okay.
and he was more organized with his work than the other students were.
Okay.
And
Can you put yours under there? Was your group similar or way different?
part of ours was similar and part of it was different.
Okay.
So it was kind of half and half.
Did you feel that Logan's was more correct or yours was?
Logan's.
Okay. What did you do that was different that you think kind of messed you up? Or you felt like made it not as good?
We didn't, like when we were doing ours, like with him, he did the box in the corner and then he compared like the side lengths and did area to find it. with ours we kind of were confused a little bit on how to do it, but we were thinking of different solutions and ways.
Okay. Alright. Next group. Put it under the document camera, please.
Okay. Wait, is it the right way? Okay, we thought Natalie.
You thought Natalie why?
Because, well, she explained all her work and she used theorem 3, the circle theorem 3, which made the most sense in a way to solve this part.
Mm-hmm.
And she used work and explanation to back up her answer.
Do you feel that she had the correct answer? You think the radius was 3, or do you think she made a mistake anywhere?
We think that there might have been a mistake, but
So what do you think the radius answer would be? It's right on your paper.
it's on the paper.
Yeah, at
Oh.
the top. Instead of 3, you think it's
What does that have to do with 2?
2, right
Yeah.
there next to R instead of equals
Oh,
3,
yeah.
you just do- Okay.
Yeah, yeah.
So it was an algebra mistake, or do you think her process was incorrect?
Algebra.
And what about your guys'? Can you put yours up there?
Which one's that? This one?
Yeah, the one that's on that wall.
No. Not good.
Was yours the same or completely different? Do you think yours was more correct or completely off?
Not good.
Not good.
Not good. Yeah.
All right. Thank you. Next group. Small, can you grab one of your work ones?
Raj, come on.
Right.
Serious.
All right, guys. Who did you think was correct?
Logan.
Okay, Logan. Good. Why?
Because his just made more sense out of all the other ones.
Why did it make more sense? What did you like about it? Did you like that it used area and you understood what that meant? Did you like that the algebra was clear? What part did you like?
I guess the area. Because, like, whenever we were, like, adding them, like, all together to make sure, like, they were all right and stuff like that, like, we got, like, the same answers as them and stuff.
Okay.
So.
And what about your answer?
It's this one, right?
No, it's on the line piece of paper.
Oh, I don't have that one.
Josh will get it. But did you think your answer was similar? Totally off? You didn't get an answer because you were so confused? Can you put it under the projector?
I think it was similar.
So it doesn't look like you guys used area. But you tried to do some stuff with angles. Okay.
Yeah.
All right, next group. All right, who did you guys think was right?
Logan.
Why? What'd you like about it?
He used area and the algebra was, like, clear.
Okay.
Easy to understand.
What about your guys' answer?
So, we set it up differently, but we got, like, a higher answer.
Okay. Okay, so we're gonna go over these different possibilities real quick to talk about what they're doing and understanding. Part of good math is always trying to understand what people were thinking, what the mistakes might have been, and so on. Okay. Yep. All right, so if we look right here at Luke's, Luke decided that he was going to go through this and figure out what units meant. And he decided units meant 0.91 units per centimeter. So then he could just measure the answer and find it out. What's the problem with that? It's not necessary. It's not drawn to scale is a big thing, right? As we can see, it's not always 100%. He scratched it out at one point and redid it, okay? But so it only works if it's 100% to scale, which this was not. We're going to go to Natalie's. What I like about Natalie's is she obviously used Theorem 3, which was the whole thing with tangents. Let me see my circle book real quick. That if two things on the outside, two tangents meet at an external point, they're equal. Okay? So I like that she used that. She did mess up her algebra. Okay? But otherwise, this is a legit right answer. She messed up her algebra, so this should be r equals 2. But other than that, she used theorems. She set up, we did one similar to like this when we did a tangent problem, where they made a box in it that was the radius in order to solve. Logan's. Logan didn't use any of my theorems, but he did get the right answer. You can do it this way, where you have area and you divide the area into 3 parts. It is similar to Natalie's, and then he made a square in the bottom and took the radius away for all of them. Okay? So he did use something similar to that. He just used area instead of using one of the theorems, but he legitimately got the right answer. So you guys see that while Natalie's wasn't the right answer, it was the right process. Logan had the right answer, but it was a different process than what we've been learning about circles. It just dealt with area. Okay? Aiden's. Aiden's has got some really basic problems. I think the key problem with Aiden's is he does directly identify the circle, but again, it's not necessarily drawn perfectly to scale. The line that bisects the angles at the points is equal distance from 2 tangents and passes through the center of the circle. Aiden has measured the diameter, not the radius. Constructing the circle and the triangles can be a useful introduction to the problem, but it will not provide a general solution, so you can't do it with A, B, C, which the rest of them you could. Okay? So let's go over our correct answer. The radius is 2. And you can do this multiple ways. We know, first of all, that if this is the hypotenuse, if 13 is the hypotenuse of the triangle, it has to be the diameter of the circle. That's something we're going to add to our circle book today. So half of that does have to be 6.5, so that does have to be it. Okay? So the radius, again, we could do it Natalie's method or Logan's method, and we will get the radius as 2. But then we have to look at our general answer. Okay? General answer, if we do it with area, we will get the radius equals AB over A plus B plus C. If we do it Natalie's method, we will get the radius equals A plus B minus C over 2, and those are both correct. Those are both correct answers. Okay? All right, so I need you guys to get your circle book out. And we are going to add to our circle book a blank page would be great. If the diameter is the hypotenuse, then it is a right triangle. Okay? And we're going to add a new one today. Okay? We're going to add a new one today. it's about quadrilaterals. Okay? A, B, C, and D. Okay? A quadrilateral circumscribed by a circle. A plus B equals 180, and C plus D must equal 180. All right, you guys should have your notes out in front of you now. Pull them out. We're going to go over the answers. We're going to go over the notes first, and then I will make sure you understand your homework, and then we will do go over the grading for each other. All right, guys. I will put this back up here when I'm done, but I am moving on. All right. So real quick, we're going to go over some inscribed angles just for a review. Okay? So if angle BAC is 37, that means arc BC is 74. It's twice as big. Central angles are equal. Inscribed angles are half the size. Okay? So if my inscribed angle is 48, then B to A is what? What's 48 times 2?
96.
Okay, this is 96. But it is not asking me that. It's asking me B to C. But I know because these two chords are equal that my arcs must be equal. So I'm going to do 360 minus 96. And I get 264. And then I divide 264 by 2. And I get both of these arcs are 132. Did I lose anybody with that one?
Yeah.
Okay. So we get how we get B to A is 96, right? Just double. Then I take 360, which is the whole angles for the whole circle, and I subtract 96 from it, and I get 264. I know these are equal, so I divide it by 2. Okay. Next, I want to know what angle BAC is, the inscribed angle, if my central angle is 87. So if my central angle is 87, it means the arc is 87. So it means my angle, my inscribed angle is half, which is 43.5.
How do you know all this off the top of your head?
Because I've been teaching this for a really long time. But you should be able to turn to where it says inscribed and central angles on your circle book and know all this information too. Thanks. All right. I want to know what B to C is. Why don't you guys try the next 3 on your own? And then we'll go over the answers. I'm going to give you like 5 minutes.
Are you gonna start the recording?
Nope. you guys one more minute, and then we're gonna try it. All right, guys, what did you get for D? Anybody want to share? Yep, Cheyenne? 56. Good. We just doubled 28, giving us 56. Okay, E is a little more complicated. I'm looking for angle BAC, so I'm looking for this angle down here. It is 19. Let's talk about how we got that. This is 142, so my arc is 142. This is a semicircle, so I go 180 minus 142, and I end up with the arc here being 38, and then I took half of 38, and gave me 19.
That's not
What did you do?
So I just flipped the 142 on the other side of the angle.
Okay.
So it's 0.
Yeah.
Circle.
Yeah.
And then I just did I guess I kind of did the same thing you did, but I didn't do the outside, so I just did it.
That's fine. Yes, Maya. So 180 minus 142 is 38. So we have a semicircle. Okay. Next one, guys. We want to know BAC. We want to know this angle right here. It is 21. Okay. Well, this whole arc right here is also 138. So I'm going to go 180 minus 138 gives me this arc right here, which is 42. And then half of 42 is 21. Okay. All right, let's do the bottom ones. I want to know what x is. So I'm going to go 180 minus 25 gives me 155. Remember, because we just learned that today, that the opposites have to add up to 180. Okay, let's find x
Wait.
and y.
Wait, does this
Wouldn't it be, what
make
about,
sense?
oh, okay.
Did you just find
Yeah.
X?
That's all you have to do.
Oh, no, I thought you were saying X and Y was supposed to be an X.
No, x and y for the next one. Yeah.
So it's 95.
So 180 minus 95 is going to equal what y is. So that's going to be 85 equals y. 85 degrees equals y. And 180 minus 87 is what x is equal. So x equals, yep. Okay. It's 50. The degree symbol didn't work really well when I was doing that. Okay, so these are both 50. This is x. We got to figure out what it is.
Just say
180 minus 50.
Do you do that all the time?
Mm-hmm. Leaves us with 130.
Why are you minus something?
All right. D, x equals 180 minus 85, so it equals what?
95.
That's it.
Oh my gosh, I actually understand this.
Okay. So we are going to look at our homework and make sure we understand all of this. All right. If this is 30, what's J? So remember, this is 90 because it's the diameter is the hypotenuse. So I'm going to go 180 minus 90 minus 30.
It would be 60.
Yes, 60 degrees.
So if it's a triangle, you subtract.
If it's a right triangle.
Are all of them right
let's do number 8. If W is 66, Y is 180 minus 66. 114. Okay? That's it.